Okay, so today we're going to continue with our Arduino journey. And in the previous class, in your previous class, we have looked into basic digital pin out. So for ESP 8286, the known MC version. Okay, so the known MC version basically will display or will put the label. You can read the label on top of the microcontroller, which label from D0 to D8, which usually you can just use them for your general purpose. So GP means that general purpose input output pins. So you can make it into either input or output. You can connect them to either modules. But however, there are also some not issues, but you have to understand that each pin out, they have double operation. They have multiple operation to the pin out. So it doesn't mean that you can just straight away use that pin, even though it basically labeled as a digital pin or the D0, D1 until D8. But not all pin are created equal, so you have to be very careful, and it is very important to read the documentation, details documentation for each microcontroller. Different microcontroller, they have different pin layout, they have different characteristic, they have different requirement. So it is very important to read them. This is not just like when you are buying like any electronic equipment, you can just throw away the manual and then you can just straight away operate them. No, it doesn't. You cannot do that with a microcontroller. You have to really understand them very, very well through their documentation, through their the what we call a specification. Okay, so read them, understand them, and if possible, print the pin out, print the documentation, so that you remember them. Okay, so this is a full flash computer, a microcomputer. All right, so sometimes if you want to make your life easier, you can define your pin out so that you don't get confused, because the pin out number, they are different than the one that label, and the label on the silk screen, they are different. Okay, the number that you want to use when you want to program them. D0 refer to pin number 16, D1 refer to pin number 5, D4, D2, and so on and so forth. So you really have to think twice. But with this setup, you don't have to. You can just take the value and then you just straight away use the digital pin definition directly on your programming. Okay, so this is just a pin definition, just to make your life easier. A little bit easier, not easier, a little bit. All right. There are three most used function instruction in Arduino to set up the pin mode. So either you want to set the pin mode as a digital, as an input or as an output. So all the pins can be defined as input and output. Either you want to digital write, so you want to output, or you want to read the data, you use what we call as digital read. Okay, so each pin it can be used for input and output operation. So input means that you get data from sensor. Output, you want to output the signal back to the output component, such as display or servo or LED. So anything that buzzer, okay, anything that will be defined, or the component that can produce an output for feedback. All right. Input sensor, most of the time we want sensor. Sensor will provide the data to the input signal, input pin, and then you can read the data, and then you can just display back the data, or you can do some processing, store the data over the database, and then that's it. All right. So there are three most used instructions. Okay, we're going to use them a lot later after this. The other things that I built, okay, this is what we call as the training board. I call it training board. So sometimes you can just use the, what we call it, the breadboard. These white things here, this is what we call as a breadboard. Okay, so this breadboard here, this one, this basically allow you to quickly connect all your electronic component on a piece of board. Okay, so you can just connect them, and then you can just jump all the wire by using jumper cable. So jumper cable, for example, like the one that I have here, but for this one, you need male jumper cable. Okay, so male jumper cable means like something like, so you can see this. Okay, this is what we call as a jumper cable. So this jumper cable here, I hope you can see them somewhere. Okay, this one. So this jumper cable, basically you can just connect them on board, and then you can then jump to the intended component that you want to use. Okay, so those are jumper cable. So you might need to buy this a lot, because sometimes you might lose them somewhere, or you might have issues with the cable connectivity inside. They sometimes, if you leave it for a very long time and you don't use them, they will disconnect, or sometimes cut off from the inside. So if they cut off from the inside, you might lose connectivity. And then if you don't have connectivity, you might have issues with your electronic project. Okay, so sometimes it is easier for you to have what we call as the multimeter, something like this one. Okay, so yeah, again, there's a lot of equipment in this subject. So multimeter like the one that I have here, this one I bought through TikTok. So this is quite cheap actually, surprisingly cheap. But this is auto multimeter that allow me to easily test my component. So this is a very handy tools to have. Okay, a very good friend to electronic engineer, to IoT people, to those who are using electronic component. The multimeter, something like this, is very important to have. Okay, like for example, that I want to test. Okay, this is just a simple test. So I need to turn on this just to make sure that if my cable is working or not. So I can use this to check them. I can just connect between these two terminal here. So and here and here. So you can hear a sound, that buzzing sound. That means that there's a full connectivity for this wire. Okay, but if you don't hear any sound, or there's no value coming out from your multimeter, that's telling you that this is no use, this is no good. So you cannot use them, because you cannot conduct electricity, you cannot conduct current at all. So throw it away. You cannot use them anymore. So again, multimeter is a very good friend to you. So a must-have tool. It's like calculator when you're doing your SPM. Okay, calculator is a good friend for you doing your SPM, your AdMath, your mathematics. It's basically the same with electronics. Multimeter is your best friend. Okay. All right. Get this. So again, more budget. I cannot do anything because this is the nature of the subject. It require some amount of money to be put away. And if you're really into this, it's going to help you a lot later on to understand how to use multimeter, how to make sure that your electronic component is working. And even if you have resistor, you want, because when you use the resistor, there are a lot of resistor value. So you need to know which resistor value they are, because sometimes it's quite hard to read them. There's even a color on the resistor. You can do the reference, but if you have like bad eyes like me, like I'm short-sighted now, I'm old, so having to read them like very hard. And you can just use multimeter and just connect them, and then the multimeter will tell you this capacitor, this resistor is how many ohm easily. Okay, so that you can just use them to reduce the electronic current, the current that coming through in your circuit. All right. Okay, always Multimeter is your good friend. Coming back to the training board. So the training board that I have here, so the one that I put it here, this is the training board that I built, that I developed this just for training. There's no need for you to have one, but I'm just telling you that we do have this one. So this basically allow you to simplify your project. So you can, all you need to do is just connect your microcontroller here, and then you can just straight away use all the pin out, and then just connect them to your sensor, to your servo, to your input and output component easily. And then you can choose between either 3.3 volt or 5 volt. So that's very, very easy. Okay. So the signal wire, the cable, the positive and negative, everything has been laid out on this side, on the right side here. And this can be like very quick prototyping board that you can just have. And even my robot also use them. So this is the one basically that I built to power my robot, which require high power. So I do have higher, what we call as a regulator, step down regulator with 3 amp of output, which to enough to supply all my servo. All right. All right. So okay. As I mentioned before, digital read, pin mode. So those are your good friend in Arduino programming. Reading data or writing back the data, which is actually you just writing back the instruction to pull the voltage up or pull the voltage low, up, high or low. But again, you have to understand ESP use high-low and low-high principle. So high is low, low is high. Means that high means that no current, low is high current. So bear that in mind. All right. So as you can see here, it's very simple. If you look into the programming, this is a C++ like programming, or even some kind of Java also a little bit. Okay, so you can see your definition up here, or if you have any variable that you want to define, you can put it like at the top of your programming file, and then set up only if you want to run it only one time, and usually for initialization, initialize value, setting up the mode, the type of either the pin as an input or as an output. And then within the loop function, this is where whatever instruction that you have to make it run forever. Okay, so the loop will always run forever. So whenever you start your microcontroller, the logic, okay, it will always go from the top to the bottom. Okay, so that's just a normal programming. Top, bottom. Okay, it started at the top, so it started with all the definition. If you have any object creation at the top, so it will create that object, and then go to the setup, and then within the setup, if you initialize your object or initialize your variable value, set up your pin mode type, so do that in the setup function. And then whatever that you need to run forever, you put it into, or we call it the opcode, operation code. So the operation code is basically run in the loop. Okay, this is run forever until the power is shut down. All right, so it's very methodical. Okay, C programming is very easy to understand because it runs based on highly methodical function. Okay, it's very straightforward. But unless later on when we invoke object-oriented a little bit, because object-oriented, someone maybe they have issues understanding of how object is being created, passing parameter, object class creation, constructor, setter and getter, and then method. So those might, if you are not familiar with object-oriented, you might have an issues with that. But most of the time, C programming or the Arduino programming at its fundamental level is very easy to understand. It's very straightforward. Okay. Okay, the one that we have here, this is a LED. So the LED defined through DO and D4. Okay, good. Because sometimes I've been with like most of the time with IT students, this is my first encounter with computer science students, so I'm not sure. I have no idea what to expect from you guys. So I hope you can follow what I'm saying here. All right. Okay, so very clear, very straightforward. Uh, let, let us work with the sensor now. Okay, so DHT sensor. So this is basically one of the most famous sensor, DHT11. Missing the 11 there. This is DHT11. There are new, there are other variety of DHT, but usually DHT11 or DHT22, basically the most used sensor if you want to learn about sensor programming. It's very easy to use. So for the DHT sensor, usually you have only 3 pin, okay, something like this. The pin basically, no, sorry, this one basically they have analog and digital. If you found out that your sensor basically contain 4 wires, sensor, sensor, not output component. If there's a 4 output pins, means that one of the output allow you to read the data in analog mode. Okay, analog mode. So one of the pin as a digital, the other one as an analog. So it means that you can read the data in the analog as an analog data, but you have to do the translation of the analog data. But it is easier just to use a digital value, because the digital value, they just spill out straight away the value, the temperature, through the discrete digital data. Okay, so your microcontroller, they comes with the multiplexer, they're being able to translate the digital value straight away into the value itself. Okay, like Celsius and Fahrenheit, you can just straight away get the value from the digital pin. But usually, but this one, because when I use the software here, they call it freezing software, just to do the drawing, they don't have the HT11 in 3-pin mode. But most of the time, the HT11 comes in 3-pin mode. So it means that you have to use them. Where's my HT11? I'm looking for them. Where's my... Okay, so that's why it's much easier for me to have like online class, because if something that I don't have, I can just pick up from my lab and then I can just straight away show to you. So this is my DHT11. I can show it to you. All right, so this is the sensor. Okay, it's very straightforward sensor. And it basically contain 3-pin outs. Okay, you can see the pin, the 3 pins there. Okay, there's 3 pins there. Okay, so those pins basically like this one. Okay, basically the same one. Okay, so these pins basically when you look at the hold on. All right. Let me just fire up the specification. Okay, the way that you need to do whenever you want to connect to any type of sensor, you have to understand there are 2 things: specification and pin out. So let me just pull out the specification, the HT11 spec. Look for them. Okay, like for example, like this one. So as you can see, the DHT11, this is a digital temperature and humidity sensor. So it means that they can provide you with 2 value, temperature and humidity. The working voltage here, okay, this is a very important data sheet. It can work within 3.3 to 5.5 volts. So which means that whatever voltage that you want to provide to the sensor, it needed to be between that voltage only. And for ESP, usually you can just take out the you can just pick up the voltage, V in voltage in from the V in pin, the 3.3 V pin. So that's basically positive, and then you can just ground it to the ground pin. So you have two pins there, positive and negative, and ESP will provide easily 3.3 volt, okay, for each pin. So you don't have to worry about that. So you can take from them. Humidity measurement between 20 to 95% within 0 to 50 degrees Celsius. So basically, will provide you with that value. Humidity measurement accuracy, temperature measurement 0 to 50 degrees Celsius only. Okay, you cannot go beyond than that. Means that if you have like very hot situation that you want to measure beyond 50 degrees Celsius, no, because there's a plastic. You can look at the plastic casing there, so it will melt. So don't go beyond 50 degrees Celsius. Measurement accuracy 2 degrees Celsius plus minus. So it means that if you need high accuracy temperature, this is not the best sensor for you. All right, this is also another important one. Current use, 2.5 milliampere. So this is the current that needed by this microcontroller. So, but you don't have to worry because each pin on the ESP, they can provide easily 2.5 milliampere so that it can be used to power the sensor. So that's also very, very important information that you need to understand. Sampling rate, this is basically how many times that you can read the data. This information basically provided 1 Hertz, means that 1 cycle, 1 second. So it means that you can collect the data every second. So you cannot collect less than that because that's basically the sampling rate or the clock rate that it run. So you have to have that also. Sizing, if you want to later on, you want to put it on a microcontroller, on a PCB or whatnot. So also important. Output signal for DHT11, output signal is a digital signal. Most of the time it's digital signal. I don't see any more. Yeah, the what do you call it? The bare bone version, they comes with 4 pins. There's a bare bone version, but this one, it basically already being put on a PCB board. So this is a PCB, comes with PCB, and then the output only 3 pins, so that you don't have to worry about. So it's only PCB here. Yeah, there's no interpreter. It already comes inside the casing, the blue casing here. So 1 digital pin and 2 power pin. Okay, positive and negative, 3.3 volt and ground pin. So here you have positive and negative left and right. And at the center, you have the digital pin. So the data pin is at the center. All right. And the other one that you need to pull out also the pin out. Okay. So there are also details that you guys look into the picture here. You can see clearly VCC in this format. VCC, this is 3.3 volt. This is the data and this is the ground. So it means that you need to connect one to the ground, one to 3.3, and the other one to the D, whatever D that you're choosing from. Okay. All right. So those are the basic. Okay, so for DHT11, so you have to understand there are libraries pre-built for them. Okay, there's already a library for them. So you can just use the library, or if you're up to the challenge, you can just build the library on your own. But the library is already there, so this is just a component base, which you can just import the library into your project. All right, but there's a I'm not quite sure what's the issue with the DHT library. Okay, like for example, usually when you want to use DHP in your project, like let me just create new one. All right, so I just create new one. Okay, this is new project I would like to use. So whenever you want to use a certain library, okay, so you want to use certain library, all you need to do is you can just go to this library manager and you can just search for the HT. Like if you wanted to use the HT11, so you can just search from there. Just pull that up, full screen. So you can just go to the library manager, make sure that you're connected to the internet. Okay, make sure you're connected to the internet because all the library, they're being pulled from Git repo, most of the repo for Arduino. And then this is basically where you can just search for the library. All right, so there are so many library for the HT11 that can be a little bit hard for you to look around. And since the DHT11 can see the simple DHT, tiny DHT, DHT11, ESP8266, DHT ESP, so many of them. Okay, ESP11, so it can be a little bit try and error sometimes. Okay, try and error. So, for example, the one that I already installed, because the one that I have here, it's already this one. So the one that I have here is DHT11. And sometimes you might have issues with the library because they are not compatible with ESP8266. Reason being is that it's based on the architecture. Okay, they call it the AVR architecture. And since I've said this many times before, ESP8266 by default program through Lua script. They call it Lua script. Okay, not by Arduino IDE. The Lua script is something like similar to Python, and the original programming basically through Lua. But Lua is not that very famous or used programming, microcontroller programming. So someone come out with the Arduino version, IDE version, the Arduino library version for the ESP. So you might have issues. So it is something that you have to try first. Let's see if the library is working or not. So for example, the one that I have here is by DF Robot. Okay, DF Robot basically one of the most famous library provider, library developer for sensor because they came from Adafruit. So Adafruit, if you know about Adafruit or you know the company, this is a company based in the US. I think US or UK, I forgot about the company. So Adafruit or Fruit industry, this is one of the big company that develop sensor and also all the library that we have nowadays. Any other company after that, basically they just copy from Adafruit the sensor and then they produce over in China and that's it. Okay, and become very cheap. But the original version comes from Adafruit and it's rather expensive. Okay. For example, that the HT11, if you want to buy the Adafruit version, the ESP or the Adafruit version of the sensor, it can be quite expensive a little bit compared to the one that comes from China. Like 7 ringgit, 5 ringgit, 3 ringgit, you already got one sensor. The original version can be like very expensive. Even the same with Arduino Uno here. The original version from Italy can cost you around 80 ringgit. But the China prefab version only costs you like a few bucks. Okay, very cheap. So quality cannot be like differentiate. Sometimes it works, sometimes it doesn't work. So hit and miss lah. Yeah. All right. So the one that I already have here is the FT11 version 1.0. So I'm not quite sure the one this version can work or not. So let's see if it can work or not. If you want to install, just press button install. So the one that I have here is version 1. It's only like version 1 or already available. No other version. Other version, this one, it says about you can just pull out the details and then see if it is compatible with ESP. But let's try with this one. So if you want to use this, like the one that let me just remove them first. So if you want to use the DF robot version, you can just install. Or if you want to use a different version, you can just read the details, what they're providing actually. This one, it seems like it worked with ESP32. This one works with it says should be able to work. And miss, as I mentioned before, hit or miss. So you can just give it a try. If it work, it work. If it doesn't work, you have to move to a different sensor, to a different library. This one, it says about 11. This one also says about 11. I'm not sure, so sure yet. Because I use the one that I have in my own library. I have my own library, so I already have them. I'm sure they work. But I'm sharing the way that how we program things in Arduino IDE, so that you can see. It takes a little bit of time. It takes a little bit of effort, understanding the reason, because it is not basically the same with your traditional, typical programming. Okay, it basically involves hardware, and hardware also require hardware debugging, firmware debugging, so many things that you have to put in mind. Okay, susah lah. Yang mana tak minat programming tu, I am very very sorry. Okay, tak minat technical punya stuff tu susah lah awak nak hidup kan dengan this type of development. Alright, so let's start. Let's start with this. Okay, actually the programming is quite short. It's quite simple. The one that I have here is basically the library that I already have. But let's see that if you wanted to use DHT11, so this library here, I'm going to quickly take my code and then just put it inside Arduino IDE. Okay, just something like this. All right. So, as we can see here, this is include DHT.h, which basically just to include the library. But I already removed all the DHT library yet from this project. Okay, and then I define my pinout so that I can use D4 from pinout 2. So you can just use D4 from your microcontroller here. So D4 is D0, 1, 2, 3, 4, right before the 3.3 volt. So you can just connect them to the data. And then setup here, this is just a serial begin. This is just to print out the value on your serial monitor. And then this is the object that we created from our DHT. So actually the name here can be a little misleading. Usually the name of the class can be like capital letter, but the one that we have here is basically defined as DHT, the name of the class. And DHT is the name of the object. So you can just either you can make it smaller or capital letter later. All right, so we have DHT object. And then to read the data, okay? So the read the data, the functions or the method that comes with the DHT class called read11, okay? Read11 D4. And then when we print out the value, we can straight away print out the value by using serial print. Serial print line, the object DHT dot temperature, and the other one is DHT dot humidity. This might not work with the library that if we use someone else's library. So let's just entertain the idea first. All right. So every time you want to compile, make sure that you save the file first. So I'm looking where I put my kat mana saya letak saya letak dalam document but not in the OneDrive document in my oops. Supposed to be over there. Is that document here? Supposed to be here. Yeah. This one. So I'm going to give it like DHT example. Okay, you can give it any names, DHT, and I put it DHT example. Okay. So this is a project. So the first thing, usually, if you want to make sure that your code is working or not, you press the verify button here. So if you press the verify button, your Arduino will try to compile the code based on the board that you selected here. So it seems that my DHT seems to not saying anything, means that my library is already here. So let me try to look for the library. This is the library. This is the header for the library, header file for the library. Double temperature. This is the library. So this is basically where I get the library, main DHT lib. Okay, so the library provided by Arduino website. Okay, this is basically where I get the library. This is the file that I'm looking for, dht.cpp. So if you want to look into details, you can just go into details. But I'm looking at, it's supposed to be under library folder there. This is the location. This is the, oh, I already have the library since it's already here. This is DHT. I'm not quite sure if this is the, yeah, this is dht.cpp. This is the file. Okay. So this is the file. So if you want to look at the file, so it's basically there. So I already installed the library actually. So it's been there for a very long time. But if you don't have, or if you wanted to use the library, you can use the library from the link that I have here. You can just download the library here. But this library is a confirmed working library because I've tested already many times. So the library is working. But if you need to look at the library first, okay, you need to understand the library first. But this one seems to be working because the library is already there. I can just clearly can check if you just press the control button and hover on top of your library include name. You can clearly see there the location of the library. But here again, I put it into OneDrive, and the OneDrive can be a little bit messed up if you don't connect it to the internet. If the library is not properly downloaded into the directory of your computer, you might get issues with that. So I have issues with my OneDrive because I have two OneDrive, and then the one from UM and the one for my personal. So this one, I think this one is personal, maybe. Okay, so the library is already there. But if you don't have yet the library, you can just download them and install them by using what we call as this method here. Add zip library. Okay, so sometimes the library is not available or the library is not working, and it can be a little bit tedious for looking for the library. You can use library that already been tested working with that particular sensor. So the one that I use here is a confirm working, so I don't have to worry about if the library is not compatible with my microcontroller or the library cannot be used with the sensor. So those kind of thinking that you have to put in mind. It can be a little bit intimidating. It can be a little bit challenging for you. But that's basically how it is. There's no other way. There's no other way. You have to go through the learning process. Okay. The one that I have here is I downloaded this library from the ht.zip and then put it into use the sketch include library add zip library. So when you add the zip libraries, you have to download first the library, the zip library, and then you can just select that file and it will automatically unzip into the folder that I just mentioned, the one that we have in this folder here. It will do that automatically. It will put it inside this directory. Okay. Oops. I'm just only taking that one. I want this. Okay. So just okay, it will always put it into this folder. This is a library folder. So whenever you install library, this is where the library will be, the folder of the library, all the header file and the CPP file will be inside here, okay, automatically. So you have to look at yours. So mine is in this folder, unfortunately inside OneDrive folder. There's a good things and bad things. Good things that will automatically back up my library. So if I have issues with my computer, my library will be always available there. I can just pull them back. But the bad thing is that you need to always connect it to the internet, making sure that the library is available locally on your computer. That's the thing. Okay, so this is basically the folder. As you can see here, this is some of the library that I already have. But I do have this other library also. They call it the DHT sensor library. So they might get confused, but I don't think so, because whenever I selected here, it chooses the one from DHT.h, not the one from the other library. Sometimes they have issues with multiple library detected. So they have collision between library, but Arduino is smart enough to identify which library that they can use, which library that they cannot use. If you have two or more library of the same library name, okay? So you don't have to worry much about that. But again, one size doesn't fit all, so you have to really understand. You have to read the output down here. So it seems to be working. And next, what you need now is to connect. Good, awak tak nampak sebab connection ni. Hopefully, awak nampak saya tak kat situ? Ada muka saya tak? Awak nampak tak muka saya yang dah tua tu? Can you guys see me actually? Nampak. Okay, good. Saya tak boleh nak besarkan ni. Habis besar dah ni. Ke ada cara saya boleh besar full screen? Mirror my zoom to fit, video adjustment, show floating. Tak ada. Dia lebih besar yang tu saja. Apalah, saya awak nampak lah nah. Besar kan awak nampak kan? Besar sikit lah kan? Okay. So, ambil awak punya microcontroller. Ambil awak punya sensor. Kat sini. Sensor DHT. And then, ambil kabel jumper. So, kalau malas, kalau tak nak gunakan, sebab saya ni malas juga, tak nak gunakan yang ni, awak ambil male. Sebab apa? Yang ni female. Yang ni, yang ni male. Yang ni male. Awak ambil female. Okay? So, ambil 3 kabel female. Ujung-ujung dia female. Kenapa dia panggil female? Pandai-pandai lah sendiri nak faham. Okay. So, kabel sini agak panjang jugalah. Okay, so a little bit longer here. Alright, so saya ada 3 kabel. So, apa yang saya nak sekarang adalah saya akan ambil 2 kabel dahulu. Saya kena ada cermin mata. Okay, so ambil 2 kabel. Pertama sekali, ikutlah color coding. Sebab yang ni color coding saya ada kelabu dengan purple je. Kalau nak menarik lagi, awak ambil lah color coding merah dengan hitam. So, lebih senang awak nak identify. So, saya merah dengan hitam, saya tak ambil kat sini. Oh, merah saya ada. Merah saya ada. Hitam. Warna hitam ada. Oh, hitam ada. Ada. So, sebab kena ada banyak. So, saya ada merah dengan hitam. So, hitam ambil cucuk pada bahagian, you have to connect them to ground. So, there are 3 position. For ESP8266, there are 3 position of 3v3 and ground. So, you have to choose either. Tak ada masalah. You can choose either one. Okay. So, let's say I'm taking the one here that near to the D4. So, ground, I'm taking ground and putting it to ground. And the other one, I'm putting it to 3v3. So, it means that now I'm connected. This is for 3.3 volt. This one for ground. Right? So usually for data, for sensor data, we use white color or yellow color usually. But it doesn't mean it just for color coding. It just for us to make our life easier to identify them. Okay, so you have white, you use white. If you have yellow, you use yellow. If you have orange, you use orange. So just a simple color coding. So for the data, so the one that I have here is D4. So I can just use D4 connected to D4 now. Okay, the other one is connected to D4. Now there are 3 cables here. So just a little bit of messy lah. And kalau tak dalam board tu cantik sikit lah. So now I have this. Oh, sorry, tercabut pula. Kadang-kadang dia longgar. So hati-hati. Kadang-kadang dia longgar ni. Okay, so now take your DHT11 and then identify them and do the connection. So ground to negative, and then positive to positive, and out to D4. I hope my cable is okay, is working. Okay, sometimes the cable is not. Okay, so there you go. As simple as that. Okay, so you are connected to the sensor. And now you can upload. So use your data cable. Okay, make sure this is a data cable. But the one that I have here, this is quite cheap. Sometimes they do have issues. So let me just take one part here, my USB cable, put it to my, okay, and connect to your microcontroller to upload the code. So let me just connect them. And whenever you want to upload, okay, let me just put it at the bottom down there. So you can check first, make sure that the COM port is available. Select the COM port. Okay, so select the correct pin out. Okay. All right, and then press the upload button. Okay, so wait for this. Okay, as you can see, it is writing now. Writing, 30%, 38%, 46% until completion. 100% done. All right, so once it is done and it letting you know that leaving hard resetting via RTS pin, via reset pin. Okay, so now means that microcontroller is now supposed to be working. So to be able to read the data, because we use serial monitor, so we need to turn on our serial monitor. So as you can see, the value basically print out for every 1 second, which is 1 hertz. Okay, 1 second is 1 hertz. So every 1 second, as you can see, temperature and humidity at the bottom down here. Make sure that your baud rate is set to the baud rate of the serial begin there. Okay, serial begin must be the same. If not, if you use like for the Uno 9600, you will see this gibberish data because miscommunication. The speed is different. So when the different speed trying to be read by the serial monitor, that's basically the value that will be produced. Okay, so you need to make sure that your baud rate is set correctly to the value that we define for the serial begin to be able to read the data. Okay, from the serial port. So you can see the temperature is 25 degrees Celsius, the humidity is 49%. So if I try to increase them, so let me just try to heat up the sensor. You can see 26 degrees Celsius. Humidity is increasing because I'm using my mouse. There you go, 28 degrees Celsius. And when you leave it a little bit back, and it will slowly go down back to where it's originally came from, or the room temperature at the moment. I'm running aircon, so my room temperature will go back to 25 degrees Celsius. and then we'll start lowering the humidity and everything back to where it came from. Okay, so as simple as that. Right, so next topic here, we're going to look into infrared sensor. So the infrared sensor, for this one, you can get this from Shopee, from all the electronics, and it depends. Okay, so it depends basically what type of project that you want to build later on, what type of sensor, what type of problem that you would like to solve. So it doesn't mean that you have to buy this or you have to buy that. Yeah? It depends. Okay, because all sensor they behave the same. Certain sensor they provide value in terms of temperature and humidity. Certain sensor will provide you with the value of high or low. It basically be able to detect other or yes or no. Or certain sensor they provide you with value, okay, with called it resistance value. So that's basically how sensor work. It basically sense the environment. Okay, it sense the environment, and it changes the value of resistance in the sensor module itself. So when the resistance value changes, it basically will trigger that. It will provide that signal value to your microcontroller, and then your microcontroller will basically the one who do the decision what to do with the data that being received by this microcontroller. Okay, so if like for example the one that you have here is a infrared sensor. uh, someone passed through the sensor, and then the sensor detected high, and then will alert the microcontroller, and the microcontroller will be able to read the data, and then what to do with the data. That's the decision that the microcontroller will require to do, and you have to program that. Okay. Okay, so let's do the microcontroller. Let's do this. Again, very easy. As you can see here, it's very short code to to begin with, because this one there's no library required. Because what it does is that when it detected, it will automatically output voltage high. In this case, when high, low is high, so it'll be able to read the value. Okay, so if you guys having issues, problem, or you didn't understand, please let me know, because so far I think that you guys okay, doing good. So I just proceed. Okay, because to me this is child play. This is nothing. Okay, this is just a very simple things to do, like teaching kindergarten level of micro of programming. Should be very easy to understand, straightforward programming. So other problem, let me know. Okay. All right. So now let's do another one. New sketch. So this sketch is very simple. So as you can see, might not be worth to write the codes. Just take them all, put it there. Okay. So save this. This is going to put it into my. Later, I'm going to upload this to my Git. Right, so don't worry about you. You do have the codes. Document and sensor, and this one is a PIR example. All right. So again, you can verify all you need, all you whatever the instructions, and here if you need to do the connection here, you have to understand that I've connected this to D1. So means that for the microcontroller, where is it here? So I'm going to take this one. Let me just increase this a little bit back. Okay, I'm going to take this and then put it out. And then I'm going to connect this to the microcontroller here. And so there are 3 pins here, but this one sometimes the silk screen print a little bit blur. So you have ground, you have, this one is VCC. Is it a VCC there? I think so. It's a VCC because the silk screen. I think so. This is 5 volt. Oh, yeah, forgot. You need to read the, you need to read your infrared sensor. You need to read first, okay? Don't forget about that. Specification, okay? So PIR sensor, sensor spec. Ini pun selalu saya lupa. So read into spec. This one is, okay, this one. Low cost PIR, this one. RM3.30 only, murah je, okay? This is basically the version. So this is SR501HC. Okay, so you have to look into this now. Okay, now the operating voltage is a little bit higher. So you have to understand that level output is 3.3 low and high. So it means that it will require 4.5. So my example here, it seems still to work, can be worked with 3.3. But we'll see. But we don't have to worry because we have 5 volt output that we can get from VIN. So you should be able to, if we are unable to do that, we can get the voltage from VIN because VIN provide you 5 volt. So there should be no problem to be able to get that if we need them. But usually, sometimes they have the spec out, but it still work in the 3.3 voltage situation. Current require like 50 microamp. Level output high and low is 3.3 volt and low is 0 volt, 1 and 0. Okay, high and low. Trigger cannot be repeated. H can be repeated trigger. All right. So delay time is 200 milliseconds. So it means that if you want to put delay, you can put delay between this time. Baud dimension, angle, cone. So this is the angle 100 degree that the cone can detect. Lens sensor, okay, should be okay. Just for the just to make sure. Voltage requirement. Okay, we require 5 to 20 volts, so it is recommended to use 5 to 40 to 20 volt. Okay, so we can use 5 to 40 volt, but it's still working if you put a 3.3 volt. But the requirement here will require 5 volt. Okay. 5 to 20 volt. All right. So it means that I need to take this to here, down there. Okay. I put delay as 1 second, 1 second delay, but you can put it like 500 millisecond to be able to, because the specification says so. Okay, you can read the specification. And the one that I have, 5 to 200 second. So it means that the delay, oh, sorry, this is second, not millisecond. The delay time. The block time is 2.5 seconds. So it means that I need to increase that to 2 seconds, but to 5-second delay. So a bit higher. Okay. Let's try the code first. And the connectivity. So positive, negative, left, right, ground, and the data should be to the right. So ground connected to ground, the data right in the middle, and voltage to the left, to the right. Okay. This is the connection. But the connection now, I put it to D4. So this one is D1. So I'm going to take this and put it to D1. Okay, so now I'm changing this to D1. And then we'll try to compile this and let's see if you are able to use this. If you need 5 volt, so we might need to change to 5 volt. So let's try that. I'm going to upload this. So let's see. Oops. Oh, the port is not provided. Yeah, again. Last time they can do it automatically. I'm not sure why they didn't do that this time. It's supposed to be automatic. No port provided. I already have that. There you go. Trying to connect. Okay, 100% reset. So let's see the serial monitor. Hold on. So it will only produce 1 and 0. Let's check that. Sometimes I need to adjust the sensor to supposed to be there, supposed to be stable. Hold on. Sorry, because the sensor is down here, down there. Let me try to check because the value they're supposed to be produce a very stable value, but it doesn't seem so. So if I put my hand right in the middle, I think the voltage is not enough. So let me try to use the VIN pin, connected this to VIN. Yeah, voltage not enough. So it requires VIN. So I might need to update that to change that. Because last time I think it does work, but I think the problem is that the voltage requirement, it requires 5 volt. Hold on. This is not stable. Doesn't seem stable because oh yeah, I'm supposed to be over there. So you have to, the dome supposed to be the other side. So if I put cable is supposed to be here, and then I'm going to put it over there. All right, supposed to be print out 0 now. Okay, this is 0, 0, 0, 0. It's supposed no 1 because it's over there. There's no infrared source over there. So now it print out 0. So if I put infrared, there you go. You can see that's detected 1, 1, 1, 1, 1. So it needed to move. It needed to move. It needed to move. If you just stationary, it will detect it not 0 movement. And then if you move again, if you leave it, it shows 0, 0, 0, 0, 0. Means that no detection. Okay, it's no detection there. Right, no detection. Okay, so put something, detection, and then do whatever that you want with that. So sound alarm, or update your real-time database, and then the application will alert someone is in that vicinity, in that area. So whatever that you wanted to do. Okay, but in this case, just a very simple one. You can see that the value changes. That means the sensor is working. The only thing that I'm not satisfied is the voltage requirement. It does seems to say like it requires 5 volt. So let me change that back to 3.3 volt. I think last time I did use 3.3 volt only. So this is a 3.3 volt. Okay, this 3, you can see it is not stable because the voltage requirement, hold on, let me just change that back to the original position. Okay, this is 0, 1, 1. I'm not putting anything in front, so it means that the requirement is 5 volt. So there might be changes required there. So I might need to update that because last time it does seem to work, but I'm not sure why. And now it is working again. So requirement is 5 volt. So there's correction there. Put it in front, you got 1. All right. So might need to update the books a little bit. Might. So this one not supposed to be here, supposed to be this. So to do, I'm going to do 5 volt update. Right. Okay.